This is my daughter. I just made her. She's finished. My daughter is perfection. I cannot believe how cute she is. She's so little, so immature, so fresh, so precious. She's the most beautiful thing in the world because I have given her her precious life. She has so much to learn in this world. Excuse me, I'm just thinking about all the stuff I'm eager to teach her, to lead, to guide her, to give her the important knowledge that she needs to know. She's gonna be such a happy kid, and she's gonna be grown up so fabulously. I love you, my dear. And I can't wait to give you classes after classes that teaches you the important scientific things that you need to know growing up and stepping forward in this society. Now, let's get into lesson 1. Now, my daughter, it's time for the most important class, your very first class. Today, I'm going to give you a physics class. And it is very important, my dear, that you're going to be homeschooled because you're different from all the other kids. And the outside world is not real. So, today we're going to learn about Ohm's Law. Why do we have to learn about Ohm's Law? Because it is integral to your health. You need to keep track of your blood pressure and blood flow and your blood qualities. You want to keep track of your health. You want to keep track about your heartbeat, your heart rate. So, let's get into it. Ohm's Law is a very simple yet true definition. R resistance equal to the potential difference. Voltages, it's a potential difference. I'll explain that to you later. Divided by the current in amps. And resistance, the unit that represents resistance is ohms, named after the famous scientist, Mr. Ohm, your father. And the unit for voltage, the potential difference, is volt. For current, it's amps. My years of science experience tells me that voltage is the potential difference across the component, such as the potential difference across different ends of your batteries. So just imagine that it's the heart that's pumping blood across your body, and that's what potential difference is to you, my dear daughter. And when measuring the bloodstream, we use current. Current is 1 coulomb of charge per second flow through any given point in circuitry. I hope you have been taking notes because those are very important health scientific knowledges. They're very important health scientific truths. And if we keep going with the Ohm's law, it is defined that it has the resistance. The resistance is the energy consumed by the electronic components in the circuitry. So when electronics move through a metal, such as a metal wire, electrical wire, they interact with the positive ions and transfer energy to the positive ions. For example, if you have too much current, your wire heats up, and that's the least thing we would want to know. We would like to see happening. So you have to measure your current every day. You have to pop those multimeters and put it in your bloodstream, and that's how you're going to learn how to measure the volts and the amps, the potential difference and the current of your body. And next we have to talk about a parallel circuit and a series circuit. Let's start from the series circuit. This is a series circuit because everything is connected along the same line. They're along the same power line and they're on the series circuit. And in series circuits, the voltage adds up. This is volt 1, this is volt 2, and the entire volt is volt. So when you measure these volts, you'll find out that the entire voltage of the circuit equals 2 volt across component 1 and the potential difference volt across component 2. I see that you're having a little bit of difficulties thinking about the potential difference and the volt. They're basically the same thing, but when we talk about volts, you have to understand what it means. It is the potential difference. Good. I think we're working this homeschooling thing out perfectly, my dear. And the next thing is the parallel circuit. This is the power source, your source of life. This is a parallel circuit. As you can see, a power line is divided in 2 streams and then combined together. And that is a parallel circuit because they're not in a series. They're not along the same line. There's a division of power between them. So let's say the current consumed by this component is I1, and the current consumed by this component is I2, and the current of the entire circuit is I. And in a parallel circuit, I equals I1 plus I2. So it is truly amazing how science is, in the end, a truth in science. They just really make sense. The truth of science is fascinating because what are the odds in the world that you see in a series circuit that the voltage adds up to the entire voltage, but in a parallel circuit the entire current adds up to the entire current. The 2 current adds up to the entire thing. They equals with each other. That's when you know that you found an eternal truth that's applicable to any situations. That's great scientific finding. That's a groundbreaking scientific finding, and that's the milestone of the scientific findings that defines our modern life. It's the magnificent tool that humans had learned upon themselves and expanded it. Without these, you're not going to be here today. There's no you. There's no making of automatic things. So, my dear, I hope you have learned this first very important physics class. And next, we shall move on to mathematics, which I have great expectations of.